Welcome to semester 2 for AQR, where the third quarter is going to be focusing on statistics type of stuff. So we're going to start off looking at some statistical information, some terminology, some vocab today, and then go from there. So without further ado, let's get started. So let's talk about real quick, what is statistics? It's the science of collecting, organizing, and interpreting data. So knowing some terminology can help us evaluate some evidence, statistical evidence. So looking at data, what is data? We've heard that word before. That's just facts and statistics collected together for reference or analysis. And then we have what's called individuals, which could be people, animals, or things. And then we've heard the word variable before. It's an attribute or property of an individual that can be assigned a value, expressed as numbers, or by groupings. So, and then lastly, on this, we have distribution, which we'll talk about in a few units more specifically, but that's viewing data as a whole rather than individual values. So variables, they can be expressed as numerical or categories. We call these two types of variables quantitative and categorical. So quantitative is going to be our numerical values. Categorical is going to be kind of our grouping, our non-numerical. But it's not always the case. There's some specific categorical ones that will be numbers but are not quantitative. And we'll see if we can figure out what those are here in a second. So quantitative. For quantitative, we have two types. The first type we're going to look at is called continuous quantitative. This could include decimals. So think about things, typically things that you can measure, like the height of children, weight, the weight of cars, the time you wake up in the morning, the speed of a train. So think about if, like what the answer or the result of something like this would be. They would all be numerical, right? The temperature, those are all numerical. Discrete quantitative is also numerical, but think about this as, can you count that thing? Like these are things that can be counted, like the number of children in a house, for instance, the number of languages spoken, the number of students sleeping in my class. And then we also have, so that was quantitative. Then we also have categorical. So categorical will be things such like eye color, political party, things to that nature. So let's see if we can figure out what, if the following would be examples of categorical or quantitative variables. So if you're watching this video for the first time, see if you can figure out which each one of these things would be, and then we'll talk about it. Okay, so the very first one says Social Security number, which is a number, and yet we said it's categorical. But if you think about what the Social Security number is, that's basically the same as saying like your name. It's just that number is assigned to you. So like your Social Security number, your student ID number, while those are numbers, they are specific to you specifically. So this would be categorical. Blood pressure is going to be quantitative. That's the number that you see at the doctor's office when you go do a checkup. Breed of dogs, German Shepherds, Chihuahuas, blah, blah, blah. Those are all categorical. Age, obviously, is quantitative. That's numerical. Gender is going to be categorical. Ethnicity is categorical. How much you make in a week, quantitative. How much you pay for a plane ticket, numerical, quantitative. And then type of car is going to be categorical. All right, so let's see if we can look at just the quantitative variables for a second and see if we can classify these as discrete or continuous. So in other words, can you count that thing or not? So students in the class, can you count them? Yes, that would be discrete. Children per family can be counted. Money made in a lifetime, you can't count that. You can't count your weight. The distance traveled, you can't count. You can count the cars in the parking lot. That's the way I kind of like to think about it. So other than Social Security number, give an example of a number that is a categorical variable. So and answers will vary here. So I would encourage you, pause this video for a second, think about it, and I'll kind of give a few here, and they could be different. You don't have to write down mine, but what is something that can be considered a categorical variable that is a number? because numbers we think about as quantitative. So I said this a second ago in the video, a student ID number would be one. Another one could be a jersey number of a sports player, right? That's going to be categorical. That is a number, but it's a categorical number. It's defining that player. So example, you are preparing to study the television viewing habits of the students in your class. Describe two categorical variables and two quantitative variables that you might measure for each student. Give the unit of measurement for quantitative variables. And once again, answers will vary here. I would encourage you to pause the video for a second and think about that. So once again, if we're looking at television viewing habits, some categorical things that you may consider would be such as maybe, do you have a job? If somebody has a job, maybe they don't watch television as much potentially because they're working or things like that. What preferred streaming platform? Netflix, Hulu, whatever. Do you have extracurricular activities? Once again, your television viewing habits, depending on what it is you're trying to investigate, like this would be, valid, right? Do you have extracurriculars? If you're trying to determine if there's some kind of correlation with people that work or people that have extracurricular activities and the amount of television they watch, are those two things independent of one another? Some quantitative things that we prefer. Do you prefer movie or series? Some people like to binge watch series and things like that, and so they may spend a little more time doing that. Quantitative, hours spent streaming in a day. Maybe your GPA. Once again, maybe you're trying to consider the fact that people that maybe have higher GPAs spend more time studying and doing schoolwork rather than watching TV. All right, so here we have this chart with some information. We're just going to see if we can break down and talk about these vocabulary words, such as what are the individuals. So those can be people, places, or things. In this case, the individuals that this chart is talking about are the makes and models of the 6 types of vehicles. Which variables are categorical? So some of them have numbers in it, numerical. Actually, all of the variables have some type of number, but those are that is that type of engine. So this is an automatic 4-cylinder, automatic 6-cylinder, so on and so forth. That would be categorical, as well as engine type. Those are specific engine types. The quantitative variables are the things such as the horsepower, the miles per gallon, and the acceleration. So consider the survey question, what is your eye color? This is an example of what type of variable. That would be categorical variable. It is non-numerical, so some answer choices to that can be like green, brown, blue, hazel, things to that nature. So what I want you to do for a moment is to give an example that has not already been used of a survey question where the data from the survey would be one of the following. So in other words, think about a question that you can ask somebody where the variable is going to be categorical or quantitative. And these answers are going to vary once again, but pause the video for a second and see if you can figure out a possible question that you can ask where the results of that question would be a categorical versus quantitative. What's your favorite pizza topping? What are some possible answer choices? Sausage, cheese, pepperoni. Those are all categorical, right? What about continuous quantitative? So something that you can't count. How fast can you run a mile? I can run a mile in 6 minutes and 37 seconds. That's my fastest mile, or whatever it is. Discrete quantitative, another numerical thing that you can count. How many fingers do you have? Okay, so we're going to shift gears for a second, and we're going to look at some tables. So these should be somewhat familiar. We've seen these growing up in math classes, but we do have to be careful here, especially when we're looking at the delta math when you get here, because some of these questions are saying what fraction and some of them are saying what percent. So just make sure that we're paying attention to that. But what fraction of students are independents? So the first part of this and all of these, that's going to basically give you your total. So you're going to be looking at the totals here. That first statement, what percentage of students here? So if we look at this first one, what fraction of students? Well, this, if we look at this, the total number of students in this table is 36. So the total is 36, and which fraction out of those 36 are independent? So interpreting this table, there's 3 students that are independent. So that would just be 3 out of 36, which we would obviously reduce as to 1/12. 1 over 12. What's the fraction of females? So looking at the table, the total number of females, our females are in this top row up here. And if we look all the way over to the side, that is the total number of females. So we can see labeled right here. So we have 16 females. We want to know how many of them are Democrats. So there's 7 Democrats, 7 female Democrats out of 16 total females. What percent of Democrats are females? So now we're looking at what percent of Democrats. So our Democrats, we need to find our total Democrats. Our Democrats are grouped, our parties are grouped by columns here. So our total Democrats is 18. So I have 18 Democrats, and I want to know what percent of Democrats are females. So we have 7 females that are Democrats out of 18 total. So I would just type in 7 over 18 in my calculator, 7 divided by 18. That would give me 0.389, and then move my decimal place 2 units over to the left, or multiply that answer by 100. What percent of students are females or Democrats? And this one's a little bit tricky, only because it's kind of like that probability where we don't want to, when we looked before the break, where you can have something that happens twice, you don't want to count this as 2 separate things. So what percent of students are female or Democrats? So let's look at this first thing. What percent of, let's look at this first thing. What percent of students are female? Well, here's our total students, right? Here is our female students. So we have 16 out of 36 that are female, but this says or Democrats. So remember that or means that we're going to be adding something here. So or Democrats. Well, the total hasn't changed here, so we still have out of 36 students, but what I don't want to do is I don't want to include this, because I've already included it when I wrote my females. So I don't want to include that. So I want to only include what's left, that 11 for the males. And then I get 75%. So I want you guys to try this one real quick. I'll put my answers on there. This is the same type of problem that we just got over, just getting practice doing that. And we should have got something like this. So, in Delta Math, you need to complete the first 8 sections all the way up to the percent two-way tables, and you do need to make sure that you're careful. And I would caution you, if you are going to work ahead, make sure you have taken the notes, and this is not just like a guessing thing. I'm not going to be resetting these problems. A lot of them many of the problems are true, false, or multiple choice, and you only have 1, maybe 2 attempts on them. And if you get it wrong, it's wrong, and I'm not resetting it. So just keep that in mind. This is going to be, and I'm giving you like a forewarning now, this is going to be not just, this is going to be grading off of accuracy as well. So, but anyways, that is day 1. Welcome back. Have fun.